Kinematics, lecture number 1, kinematics of motion in straight line. There are two types of quantities, scalar quantity and vector quantity. In scalar quantity and vector quantity, magnitudes are used, units are used, but in scalar, there is no direction, but in vectors, there is direction given. For distance, what we need to understand is what is distance? It is the length of space between 2 points. The SI unit that is used for distance is normally meters, which is M, and distance is a scalar quantity. Distance is a scalar quantity. Similarly, let's work upon displacement now. Now, displacement Now, what is displacement? It is the distance from the mean position. Distance from the mean position, which gives the shortest distance between 2 points. The SI unit is still meter, but it is a vector quantity. It is a vector quantity, which means displacement has direction, where distance does not have direction. Now, similarly, so what is the speed? The speed is rate of change of distance. Speed is distance upon time. Distance upon time. The SI unit of distance is m. The SI unit of time will be taken as what? S. So that means what we can have is that the SI unit here is ms to the power -1. What is the average speed? Let's say average speed. There's a difference between speed and average speed. The average speed is total distance upon total time. Remember, it's a scalar quantity whenever we be working on speed. Similarly, there's a velocity. Similarly, there is a velocity. Now, what does velocity do? You need to understand that. Now, velocity is, remember, a vector quantity. It is a vector quantity, but it tells me the rate of change of displacement. Rate of change of displacement. It is a vector quantity. It is a vector quantity. Velocity is equal to velocity is equal to displacement upon time. So M and S, SI unit is still same, that is ms to the power negative 1. So average velocity is again same, almost similar to what we did. Average velocity will be total displacement upon total time. Average velocity can also be written as V plus U upon 2. Final versus initial divide by 2. V is your final velocity. U is your initial velocity. Okay. So there's another thing that is called acceleration. So acceleration is rate of change of velocity. It is a vector quantity. So acceleration is equal to change of velocity upon total time. So change of velocity is ms, obviously the velocity that we normally calculated, which is displacement upon time. Similarly, total time, change of velocity upon total time will give me the acceleration. So acceleration is basically v minus u upon what? T. Acceleration is basically v minus u upon t. So v is what? Final velocity. U is what? Your initial velocity upon time. V is again final velocity. U is basically your initial velocity. So that means there are a few equations that you need to understand. That is the equation of motion, movement. So let's say that if I want to find out A, so this should be V minus U upon T. V minus U upon T. So this will give me what? Normally average velocity, right? So average velocity is V plus U upon 2. Average velocity is V plus U upon 2. So V plus U upon 2 is your average velocity, which means V plus U is basically V plus U is your which means this should be S upon T is equal to V plus U upon 2. S upon T is equal to what? V plus U upon 2, which means S is equal to V plus U upon 2 multiply by it will become T. So this means this will give me the displacement. This will give me what? Displacement. So average velocity is what? Average velocity is S upon T. Velocity is basically S upon T. So that is the reason the equation of the motion will become V plus U upon 2, which means T. Now that means the equations are now the same. That means we'll be using A is equal to V minus U upon T. So V will be U plus AT. V will be U plus AT as well. So similarly, the last equation that we have is V square minus U square is equal to 2AS. V square minus U square is equal to 2AS. So these are the few equations that you need to work on. Number one is, which is S is equal to V plus U upon T, right? Multiply by what? T. V is equal to U plus AT, and V square minus U square is equal to what? 2AS. Okay, moving further, let's just work upon the same concept for uniform motion. For uniform motion. That means acceleration will be 0. Acceleration will be 0. So when we talk about speed, it will be distance upon time. When we talk about velocity, it will be displacement upon time. So this is distance and this is displacement. Displacement. So displacement it is upon time. Moving further, we need to understand that for let's say that for uniformly acceleration or deceleration, right? Acceleration or decelerating, let's say bodies. What are we going to take? We are going to use V is equal to U plus AT, S is equal to UT plus half AT square, V square minus U square is equal to what? 2AS. So the three formulas will be for uniformly accelerating and decelerating bodies, which V is equal to U plus AT, S is equal to UT plus half AT square, V square minus U square is equal to what? 2AS. For uniform or non-uniform accelerating or deceleration, acceleration or deceleration, we will be working on, if we differentiate the displacement, we'll get velocity. When we differentiate velocity, we get acceleration. Similarly, when we integrate velocity, we get displacement plus c. When we integrate acceleration, we get velocity plus c. So S is basically displacement, V is basically velocity, and T is basically time. So A is acceleration, and you know this, right? So when we are working on few things, we'll be working on that the entire concept is reviving upon the uniform or non-uniform acceleration, where the equation will be given for displacement and you will be told to find out the velocity, or the velocity will be given, you'll be told to find out the acceleration. For that, we will be needing to differentiate. But similarly, if the acceleration is given and you are told to find out velocity, you'll integrate. Similarly, if the velocity is given, you need to find the displacement, you'll be integrating. So it depends upon the question to question.